This is the most dangerous problem in mathematics, one that young mathematicians are warned not to waste their time on. It's a simple conjecture that not even the world's best mathematicians have been able to solve. Paul Erdős, a famous mathematician, said, "Mathematics is not yet ripe enough for such questions."
Squad, hold! That flag means we're only at the halfway point. First man to bring it to me gets a ride back with Agent Carter. Move, move! Come on, get up there! That's all you got! This army's in trouble! Get up there, Hawk! Come on, get up there! Nobody's got that flag in 17 years! Now fall back in the line! Come on, fall in! Let's go! Get back into formation! Rogers! I said fall in!
Thank you, sir.
Hello, Internet. I'm Matt, and I want to share with you a little epiphany of mine how I use game theory to hack the universe. And I can prove it by solving a math paradox that has been eluding intellectuals and geniuses for well over 2.5 centuries. And if you aren't familiar with game theory, the key word to understand is perspective. Now, first, let me pose you a riddle. What is the greatest force in the universe, more powerful than the Big Bang? A power so great it can both change the past and change the course of the future. Yeah, I know. But before I answer this, let me introduce you to a typical old smug accredited mathematician. Well, the Collatz conjecture, or a 3x plus 1 as more commonly called these days, is an unsolvable mathematical paradox. And it is unsolvable because if there was a solution, we would have come up with it by now. So, the instructions are as follows. Hold on a sec. Now, before we get going, there are plenty of great videos on YouTube that break down every concept that is mentioned throughout. Now, for example, for more information on 3x plus 1, there's an F ton of great, simple, or more in-depth videos online. And I recommend Veritasium and Vsauce, and there are many others. Just look to the top right to see the main theories for reference. All right, smug douchebag, take it away. Now, as I was saying, the instructions are as follows. Select a number to use as the value for x. And if the number is odd, multiply it by 3 and add 1. Then repeat with the new number as x. If the number is even, then divide the number by 2 and now repeat with the new number as x. The goal of the game is to find the starting value for x that will increase for infinity and never divide. For example, if we start with the number 1 for x, since the number 1 is odd, we'll need to multiply x by 3 plus 1, and that equals 4. Now, 4 is our new value of x. So, since 4 is an even number, we need to divide it by 2, equaling 2. And since 2 is also an even number, we need to divide 2 by 2, bringing us back to 1. And 1 is an odd number. So we have to multiply it by 3 and add 1. Now we're back at 4 again, and we're trapped in an endless loop. The reason this equation is a paradox is because it's impossible to not end up dividing into the 4, 2, 1, 4 loop. Trillions of integers have been plugged into a supercomputer, and the algorithm always collapses. It's unsolvable.
It is possible that given what we know, we may never prove the Collatz conjecture true or false.
You're gonna be taught in school that we know a bunch of stuff, and it's a lie. They're all lies. Here's this stupid little problem. Come on. Really? We can't solve this? Really? You know, it just shows math is hard. If anything, it shows that all of the things that we can solve are miracles. We have no right to have solutions to all these other problems.
For my whole life, I've thought of numbers as these incredibly regular things, full of patterns, symmetry, and repetition. But what I'm realizing only now is just how peculiar numbers really are. You can see this most clearly in the choral representation. From a simple mathematical operation comes something intricate, organic-looking, and thus far intractable to us. Do all numbers connect to this structure? Or is there some unique filament, a spindly little thread that doesn't connect to any of this, that runs off to infinity? And why is it so hard to tell? I think that's why Paul Erdős said, "Mathematics is not yet ripe enough for such questions."
Okay, so that's the Collatz conjecture, the hardest mathematical problem yet to be solved. Now, let me quickly explain game theory so you can understand how a young hacker without those fancy physics degrees was able to accomplish what the most smug and brilliant booksmart douchebags could not. Now, again, there are many great videos and examples that can explain the ins and outs of game theory, and most of your favorite and intense entertainment apply game theory in their storytelling and delivery.
Do you know what I do for the FBI? Study human behavior.
The man we're looking for, he's smart, strong, confident. He's not who you think he is.
You wouldn't know the right thing to do if it kneeled down and sucked your tiny goddamn...
I'm not going to stop the wheel. I'm going to break the wheel.
But all you need to know for this is it's effective, and what many believe is the biological hack to the human psyche. Like I said, the important keyword that I use to understand and apply game theory in my everyday life is perspective. Hacking a computer, hacking a game, hacking a person, hacking a situation, it requires an understanding of perspective. Now, not your perspective, but the other perspectives and how they coalesce. It's about defining the axioms. Whether it's a video game's point of view, a computer program's point of view, another person's point of view, and how they fit into the specific environment or situation itself. Now, game theory is understanding the other perspectives, the goals, the limitations, the barriers, and the process. Then use that information like breadcrumbs to lead the other perspectives to the outcome you desire. Kind of like Inception. And if it sounds scary, it is. It's built into the very core of our education system, of our culture, of our mass-marketed, obedient society. It's not about climbing the flagpole. It's about understanding both your perspective and the objective. Then, looking for the most logical way to bring both together. Intelligence will always defeat obedience and the ignorant, shallow peer pressure of the obedient. It's the hero's journey, a tale as old as time. So, how did I use game theory to hack the Collatz conjecture? By reversing the point of view from our individual perspective to a universal perspective. Then I based my axioms on this different perspective. If you're not sure what axiom means, it means a statement or proposition which is regarded as being established, accepted, or self-evidently true. I questioned our understanding of the axioms of mathematics using game theory. So, what is the goal of the game? How do we solve this unsolvable mathematical infinity paradox? I thought, okay, we need to avoid whole numbers. Whole numbers causes the algorithm to divide. So I thought, what do I use to redefine what constitutes a whole number? What is the closest thing to infinity that we know of? The universe. So, what is the start of the universe, as far as we know? The singularity, before the Big Bang. So, what is the universe made out of? I imagined, and I closed my eyes, and I saw an ocean of currents and particles, an ocean of energy and matter. So then I thought, okay, if I were to plug in the start of the universe into this equation, one, or the singularity, that means one is actually two parts, energy and matter. I realized my whole starting hypothesis was wrong. It's not about trying to avoid whole numbers. It's about growing my concept of a whole number. That means if one is made up of two parts, it should be halved, not multiplied. So what if the reason we haven't solved this equation is we were using the wrong perspective and the wrong axioms? What if we were trying to measure the universe from Earth with our math instead of the other way around? What if mathematics has been wrong? What if math has been missing the other half of the equation all this time?